Solving equations graphically. So leading up to today, we've solved two linear equations graphically. We've solved them algebraically by elimination and substitution. So now we're going to take an equation that we don't have any other method up until this point to solve it other than graphically. We don't have the algebraic skills yet to solve it. So what we're going to do today is we're going to graph things, but we're going to use our calculator. So have your calculator out and open. And to start, we're going to start with something really basic, something that you're easy, and then get into the more abstract of stuff that is new, that, like I said, that we don't have the algebraic skills to solve. So this two-step linear equation, just solve by your standards method. Okay, so we would add x, and then we would add 2, and we end up with that x is 3. And we would check that, obviously, by substituting that value back in to the original equation, and we would see that 7 equals 7, and that's absolutely true. So now it says use your calculator, fill out the table below for the two expressions. Circle the solution you found. Well, what are the two expressions? Well, our two expressions come from the equation. So we're going to type into our calculator 3x minus 2, and look at the table, and then 10 minus x. So if we go down to our calculator, and we type in 3x minus 2, and the other one was 10 minus x. Oops. I hit Control G. Here we go. 10 minus x. Enter. Okay. So they're not asking us to look at it graphically. They're asking us to look at it as a table. So hit that Control T. And when we scroll through this table, we see our x column, we see our first graph, that 3x minus 2, and then our second graph, our 10 minus x. So they're asking us to look at it from 0 to 4 on the x's. So from 0 to 4, and then fill in the table. So it's all we have to do is arrow up. So from 0 to 4, and we may need to have to arrow over so we can see the complete table. And then we look down here as we sort of scan through, we see that both graphs are equal at 7 when x is 3. So that's our solution right there. So we're going to fill in that table. So we have that this is -2 and 10, 1 and 9. Fill those in, and then circle the solution. The solution is right there where the two are equal to each other. So now it says, using your calculator, graph those two, which we already did, but now they're asking us to use the window from the x's, the domain from -2 to 6, and the range from -2 to 11. So they want our graph to look like this. So we just go in, and I would collapse the table, so hit Control T to get rid of the table so we can see a larger graph. So if they want our domain to go from -2, so just double click on that and type in -2. So you see that it starts to shift our graph, and 6, and hit enter, and then they want us to change the range from -2 to 11. It just gives us a different view to see. And we find the intersection point. So to find the intersection point, you're going to hit Menu, and then Analyze Graph, and then Intersection. And then down at the bottom left, it says Lower Bound. That just means move that little pointer somewhere to the left side of the intersection point and click it. Use your click pad, and then slide it over. And as you go through that intersection point, that point comes up. So there's our solution, 3, 7. And if we're asking for the solution to that, we know that it's a point, 3, 7. Okay, you can certainly draw a sketch. Okay, all right, a sketch is just that. It's just a sketch. It's not really accurate. Okay, it's just sort of an estimate. Obviously, we would put arrows on that. Okay, and now it says to solve the equation that where f of x equals g of x, you graph both f of x and g of x, and then find the intersection points. So now let's get into something that we're not familiar with. So now we've got this equation, x squared minus 11 equals negative 2x plus 4. So we don't have two linear equations equal to each other. We have a quadratic equation here. On the right-hand side, it's quadratic. On the left, on the left, it's quadratic, and on the right, it's linear. So we're going to graph this because we don't have an algebraic method to solve it. And we're going to look at the domain and the range. So they want us to change our window. So go back to your calculator, and you're going to set your first equation that you're going to type in and graph is that. You're going to see a parabola, and then you're going to type that in, and that's going to be your line, and we're going to look to see where they intersect. So go ahead and get a new page there. So our first one is x squared minus 11. Hit enter, and then control G, so we can type in the linear portion of it. So that's negative 2x plus 4. And hit enter. And they want us to change the windows, so we can see. So they want us to make that negative 8. Enter. Like I said, just double click on it till it says text. I'll do the same thing up here. Just make sure it says text. So 20. And then negative 20. Okay. Okay. So now let's use that intersect feature. So we're going to go to Menu, Analyze, Intersect. Now we have 2 points of intersection, so I'm going to just go from left to right. I'm going to start with this left-hand intersection point. So make sure your pointer is to the left side of that intersection point and click. And then it changes to upper bound. So upper bound's going to mean to the right side of the intersection point, and click, and it labels that point, and then just do it again. Okay, for our other intersection point, Menu, Analyze, Intersection, lower bound, again, be somewhere to the left of that point, slide it across, and click it again. Now we've got a bunch of our labels, sort of, well, at least I do, a bunch of mine overlapping, so you just grab them and move them. So we can see that our two intersection points are negative 5, 14, and 3, negative 2. So again, they're asking us just to provide a sketch there. So we've got our parabola, and that's not accurate at all, that line. There we go. That's a little bit better. Okay. And our 2 points of intersection here and here, and then I would list them out. 5, 14. Oops, I don't know what's going on with that. And 3, negative 2. Okay. So let's continue on. So now let's look at a third equation. It says the function f of x is equal to 2 times the absolute value of x plus 1 minus 8, is shown in the grid below. Use it to help answer the following question. So we're going to kind of keep coming back to this original equation. So it says find all the values of x that solve the equation below. Circle the points in the graph that illustrate your answer. So here's our original equation, and now they're saying set it equal to 0. So let's go. So they've got it graphed here, okay, already for us. right? They have that absolute value graphed for us. And then they said, where does it equal 0? So if we were to graph y equals 0, okay, this, like I said, this piece is already graphed for us. Call this our f of x. Well, then the right-hand side of the equation, that would be our g of x. So if this is our f of x, that could be our g of x. So in other words, where do you graph y is 0? Well, y is 0 is just the x-axis. So circle the points on the graph. Well, right there. Okay? And what are those two solutions? That happens to be x equals -5 and x equals 3. So we just solved this equation right here graphically. Okay? And they asked us just for x, so we don't have to write the intersection points, them as coordinates. They're just asking for the x. So it says find all the values of x that solve the equation shown below. Illustrate your work. Okay, so I'm going to change colors here. So again, here is our f of x that they gave us in the beginning. Well, now they're changing it to -2, so that's our g of x. So where is g of x equal to -2? In other words, where is y to -2? So y is -2, okay, all along this horizontal line. So where do those intersect? So we can, I don't know, put an oval around those. And what are those two points of intersection? Those intersect at x equals -4 and x equals a +2. Again, they're just asking for the x values where they intersect. Okay, 1, 2, 3, -4, and then 1, 2. Just the x values. If you wrote them as coordinates, this would be your -4, -2, obviously, and this would be your 2, -2. Okay, and then in part C, okay, it says find all the values of x that solve this equation shown below, and it says this one's going to take a little bit more work. Obviously, we were able to do this one without the use of the calculator because they were two pretty simple equations that we could graph pretty easily because they already gave us that absolute value graph. So let's take, okay, again, here's our original f of x. Here's our f of x, and here's our g of x. So now we've got that x minus 1. We want to see where those two intersect. So again, we could do this one by hand. It's not bad, especially because they already gave us that absolute value graph. So our g of x, x minus 1, well, our slope is 1 over 1, and our y-intercept is -1. So let's go ahead and graph that. So there's our y-intercept. And then we could go up one, right one, until it intersects. Okay, there's our first point. But obviously we know we can go back the other way. We can go down one and left one until it intersects the absolute value graph. And drawing that line where the two intersect. And we can find, again, they're just asking us for our x values. So this one is 1, 2, 3, -3, and 1, 2, 3, 4, 5. So our solutions, x equals -3 and x equals +5, and they did ask us to show the step in the checks. So if I take and I check -3, I'd say 2 and 3 plus 1 minus 8, -3, there we go, and then -3 minus 1. Go right to your calculator and let's enter this just as a little refresher. So I'm just going to go to a quick calculate page and type that in. So it started off with 2. The absolute value symbol is next to the 9 key in that menu. And we put in -3 plus 1, and then minus 8. And does it equal? The equals underneath the control key, and then negative 3 minus 1. And hit enter, and that is in fact true. Now obviously we're going to do the same thing with our other solution, which is 5. So I think I'm just going to arrow up and hit enter. Okay, so I just cut and pasted, and now let's just go back in and edit. So our x now is 5. 5, and hit enter, and that's true. Okay, so obviously let's mark down on our paper that one came out to be true, and then when we put 5 in, that one also came out to be true. Okay, last question. It gives us a quadratic, okay, this one right here, and then it gives us a linear, and it shows that it's graphed for us already over here. Which of the following sets gives all solutions to the equation where the two are equal? So they already graphed it, and they want to know the x values. So notice these aren't points because they're in curly brackets, so they're sets. So they've just given us the x values. So let's find this x value, 1, 2, 3, 4, and this x value is 1. So our solution, okay, our solution set is, excuse me, 1, 4, right? So what we've learned is that you could take any equation. I could give you the craziest looking equation, as long as you set the left side of the equal sign equal to y and graph it, and then the right side of the equation equal to, if we use function notation, g of x, and graph it. So essentially graphing two different equations, see where they intersect, and you can solve any equation.